In this lesson, we will be looking at natural logs, which are logs that are in base E. Okay? So, if we graph that equation that is up there, this one right here on our graphing calculators, which we will do in a minute, we will see that that graph approaches the number 2.718, which is the number E. It's kind of like pi that looks like a variable or a symbol, but it has a number associated with it. We know pi is associated with 3.14. E is associated with the number 2.718. Da 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 da. Okay, so I'm going to take you to your calculators here. In my y1, I've already typed that equation that's there, 1 plus 1 over x to the x power. And if we hit graph, I'll show you this here. And what we really care about is we really care about the right side to that equation. So we don't care about negative values because when we're talking about real life situations like money and radioactive substances and all of that kind of stuff, we can't have negative amounts of money that we invest or whatever. So I really care about this half right here. And you can see that that line tends to sort of flatten out or approach a number, and that number that it approaches is 2.718. If we look at our tables, and I sort of have my table set, notice my table's already down at 156, and it's getting really close to that 2.71 amount, and if I continue to scroll down, it would get even closer. Okay? That number E we see often when we compound interest, when we're talking about radioactive substances, when we're looking at population growth, and lots of other places in real life. And that E number, when we put it in terms of logs, log base E, is also written, or instead of being written as log base E is called the natural log, or it's written as ln. Okay, so log base E is written as ln, and it's called the natural log. Okay, so we are going to use our calculator, and we're going to look for some natural logs. So in this case, I need to look for the natural log of 4. There is a button on my calculator. It's kind of between the 7 and the 4. I'm going to quit out of here and go back to my main screen, and I will erase this so that's not a problem. ln is right here between the 7 and 4. The natural log of 4, if I type that into my calculator, I get this. Just like with all logs, we typically round our answers off to 4 decimal places. So the natural log of 4 comes out to be 1.3863. And again, instead of writing natural log, I could write that as log base E. So log base E of 4 is 1.3863. Or that's in logarithmic form now. So that's what it looks like in logarithmic form. If I were to switch it to exponential form, your base would be E, your exponent would be 1.3863, and your answer would be 4. Okay? On the next one, if I type in the natural log of 0.05 into my calculator, and I trust that you guys can all do that, you should get negative 0.29957. And again, instead of writing natural log right here, that means the same base or same thing as log base E. So log base E of 0.05 is about negative 2.9957. So that's one way to write it. Or if I switched it from logarithmic form, which it's in, to exponential form, your base would be E, your exponent would be negative 2.9957, and your answer would be 0.05. So I can write those either way. Okay, now I'm giving you something where we're going the other way around. And again, I want you to remember that the natural log is the same as log base E. So I can start by writing it like this if you need to. Many of you will sort of skip that step. But then I can switch this so that I switch it from logarithmic form to exponential form. And I would make that be E to the 0.6931 is x. Okay? So if I wanted to write that as exponential form, that's what it would look like. Similarly, again, I can replace the natural log with log base E. And again, lots of you can skip this step. But then sometimes it's easier to picture. Okay, so now here's my base. here's my exponent, and here's my answer. So that's what that would look like. All right, and then these are in exponential form, and you can get them back to logarithmic form. So if I'm doing logs, then this is log, my base is e, my exponent is x, and my answer is 5. So that's what that would look like. But instead of writing log base e, we write the natural log of 5 is x. Okay, so I think you can kind of figure out a shortcut here to get from here to here. I hope you can. Okay. Again, I can switch this to logarithmic form by saying it's log. My base is e. My exponent is 3x. And my answer is 5. Okay, but again, I would replace that log base e with the natural log of 3x is 5. Okay. All right, so what do you think the natural log of e is? So if we think about this, the natural log of e is, I don't know. Again, instead of natural log, you can write it in log base e. Okay, so then I can switch it to exponential form. E to the x equals e. The only way to get, and by the way, there's a 1 up here that's not written. The only way to get this to work out is that x equals 1. So the natural log of e is 1. Okay? Then if I want to know what the natural log of 1 is, again, I'm going to put an x here. So I'm going to go like this. The natural log is the same thing as log base e. That should be an x, sorry. So e to the x equals 1. I want you to think about this. The way to get 1 of any power, okay, so like 2 to the what is 1. 985 to the what power is 1. Negative 1/4 to the what power is 1. And the answer is anything to the 0 power is 1. So e to the 0 is also 1. And so x has to be 0. Which means that the ln of 1 is 0. All right, then I want you to be able to solve these here. E to the x equals 3. Lots of you can kind of figure out this shortcut, but I'll do a 1 where I don't have to do this. I'm gonna switch it to logarithmic form first. Many of you can skip this step, but if I switch it to logarithmic form, then I have log, my base would be e right here. My exponent is 3. And my answer is x. Okay? So log base e of 3 to the x would look like this. And then again, you can replace log base e with a natural log. And then this you can stick into your calculator. So the natural log of 3 is 1.0986 about. Again, round to 4 decimal places when you're doing logs. So I hope you can kind of figure out a shortcut with these, and I'm going to take that shortcut. I want to isolate this, so I'm going to divide by 4, and then I have e to the x equals 17/4. Now, if you need to switch that so that you have it in logarithmic form first, that's great. Hopefully you're realizing that you can take this shortcut and take the natural log of 17/4 will be x. Okay? So if you can't skip that step, then remember that it can switch this to logarithmic form, which is log base e of 17/4 equals x. And then, of course, the log base e can be replaced with ln. Okay? Again, type this into your calculator. X will come out to be about 1.4469. All right, and I would like to get this piece isolated by itself first. So I will add 7. And then that puts me here. And then I will divide by 5. And that puts me here. All right, and again, I'm going to take that shortcut. So the natural log of 9/5 will be negative 2x. Okay, and then obviously I can type in the natural log of 9/5 into my calculator, but I will divide by negative 2. So I will type in the natural log of 9/5, make sure you close your parentheses, and then divide by 2. And x should come out to be about negative 0.2939. All right, moving on now, kind of switching gears. Again, you can probably figure out a shortcut here, but in case you can't, this is log ln is the same as log base e of x equals 4. So this is in logarithmic form, not helping me so much. So then I can take e to the 4th power and get x. Okay? So shortcut, e to the 4th power is x here. And then you can type that into your calculator. You do have an e button on your calculator, and it's blue, and it's above the ln. So to get the e, I will go second ln to get the e, and then to the 4th power. Okay, so 54.5982 is what that comes out to be. Oops, 5982. That should be. All right, ln of 5x equals 7. Again, if you need to switch that to logarithmic form so that that helps you, that's fine. The shortcut would go e to the 7th equals 5x. And of course, to solve for x, I would need to divide by 5. So I will type into my calculator e to the 7th power. Make sure you close your parentheses. And again, to get the e, you go second ln. Okay, so I'll just type this in really quick. Second ln of e to the 7th power. And then I need to divide that answer by 5 in this case. And I get about 219.3266. All right. A couple more like this. So again, I can replace this natural log of something with e to the negative 2 equals x minus 1. I will add 1 to my answer. Go ahead and type that into your calculator. So you're going to type in e to the negative 2. Make sure you get out of your exponent and then add 1 to your answer. And x should come out to be about 1.1353. So you can check that out and make sure that that works out okay. All right, and then here we're using our same log properties that we used when logs were in any other base. Remember that ln's are in log base e, so all those log properties still hold. So because this is a plus in here, I can make this be ln of 3x times 2x, or the natural log of 6x squared. Okay, so then of course I can change this to the e to the 9th equals 6x squared. And then I can divide by 6. And then what I will need to do is I will need to take the square root of that. Technically, when I take the square root of that, I would need a plus or minus in front of that. However, you can't take the log of a negative number. So I know that up here, this quantity right here cannot be negative, and neither can that quantity, because I can't take the log or a natural log of a negative number. So actually I only need the positive root, and then I will type this into my calculator. So what I might do, because you're probably going to do this a lot in your head, is I would probably take e to the 9th and then divide my answer by 6. And then I need to take the square root of that number. So then I can take the square root of the last answer, which is second and then the negative key, in case you didn't know that. And then press enter, and I should get about 36.7493. right, then this one is very different, but you're going to think of this as factoring something. And when you factor something, I am going to take this and I'm going to move it to the other side. So I have 0 equals ln of x squared minus, and by the way, I can take this 10 and bring it down in front too, so that this actually becomes minus 10 ln of x plus 24. Okay, now I want you to think about this. If this were x squared minus 10x plus 24, I think you could picture how you would factor it like that, and you would go x and x and da, da, da. Okay, it's the same kind of thing, except for instead of x squared here, you're going to throw in an ln here, and you're going to throw in an ln here. Okay, but it will factor the same way. And by the way, you can't bring this 2 down in front because it's the whole quantity that's squared, not just the x that's squared. So you can't make that move right there. Okay? So I will factor this as ln of x times ln of x, because ln of x times ln of x makes ln of x squared. And then I can get 24 by doing 6 and 4, minus and minus right there. Okay, and then of course you'll go ln of x equals 6. ln of x equals 4. Okay, and then you can change this to the e to the 6th power is x, e to the 4th power is x, and then you can type those into your calculator. So here x should come out to be about 403.429. And here x should come out to be about 54.5982. Okay. And lastly, we have a word problem. It talks about the number of bacteria, or no, the number of a certain product that will be sold T years after the product is introduced. How many years after that product is introduced will there be 8,800 that are sold? So I will take 8,800 and put it right here. Okay. I will divide by 2,600. And that's what I have right there when I divide by 2,600. So now I need to kind of think about how I can use that little shortcut. And so I can make this be then e to the 8,800 over 2,600. And you could reduce that, of course, if you wanted to. Would be 6t plus 5. Okay, so I think you guys can picture algebraically that you're going to get an icky number for this, and then you will subtract 5 to that number, and then you will divide by 6. Okay, so that's what I'm going to type into my calculator. E to the 8,800 divided by 2,600. E to the 8,800 divided by 2,600. Okay, and then, like I said, I would subtract 5 from that number, and I'm going to press equals, and then I will divide that number by 6. And I'll get about 4.08 years, a little over 4 years. Okay, and that should do it.